In this video, we're going to look at examples of mass to atoms and molecules conversions. These are going to be two-step conversions because we're going to go mass to moles and moles to atoms and molecules, or the reverse, atoms and molecules to moles and then moles to mass. So we're putting together what we've done in the first two example videos into one problem. So the first problem here, how many atoms are in 48.10 grams of magnesium? So in this case, we're taking 48.10 grams magnesium. We want to get rid of grams. We can't convert straight from grams to atoms. There's no conversion that goes directly from grams to atoms. So we're going to go from grams to moles. 1 mole of magnesium is 24.31 grams. Then, once we have moles, we can convert 1 mole into atoms. And we remember from Avogadro's number, there are 6.02 times 10 to the 23rd atoms in a mole. So we're dividing 48.10 divided by 24.31, and that answer times 6.02 times 10 to the 23rd. From that, we'll keep the 4 significant figures, 1.191 times 10 to the 24th atoms magnesium. Next problem, what is the mass of 3.07 times 10 to the 24th atoms of zinc? This time we want to get rid of atoms and go to moles. So 1 mole is 6.02 times 10 to the 23rd atoms. Then from moles we need to go to grams. So 1 mole of zinc is 65.39 grams. So 3.07 E24 divided by 6.02 E23, and then that answer multiplied by 65.39, and we get 333 grams of zinc. Now we're going to do the same thing with a compound. So how many molecules of silver nitrate are in 86.04 grams of silver nitrate? Silver, we all remember, is +1. Nitrate is -1. So we need to find the molar mass. Silver, 107.87. Nitrogen, 14.01. Oxygen, 16 times 3, which is 48. You get 169.88 grams. So we're going to take 86.04 grams, 1 mole, moles goes on top, that's what we want to find. Grams goes on the bottom, that's what we want to cancel. And then 1 mole we want to cancel. 6.02 times 10 to the 23rd molecules. So we're going to take 86.04 divided by 169.88 and multiply by 6.02 times 10 to the 23rd. And we get 3.05 times 10 to the 23rd molecules of silver nitrate. One last problem. What is the mass of 3.04 times 10 to the 23rd molecules of carbon dioxide? So carbon dioxide, carbon 12.01, 2 oxygens, 16 times 2 for 32, we get 44.01 grams. So we're going to take 3.04 times 10 to the 23rd molecules. 1 mole equals 6.02 times 10 to the 23rd molecules. And then 1 mole equals 44.01 grams. Do that multiplication, 3 significant figures, we get 22.2 grams carbon dioxide. So here we have two-step problems, but as long as we're careful with writing our units, we've got our mole to atoms and molecules conversion using Avogadro's number, 6.02 times 10 to the 23rd, and our molar mass conversion, 1 mole is equal to the average atomic mass in grams. So this takes us through the 3 main conversions with atoms, molecules, grams, and moles.